Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are going to prove again one of the very important theorem which is called as cosine rule, and this theorem is also helpful to solve the example from next exercise. So let us try to prove the cosine rule. Here three statements are there. So method to prove all the three statement is one and the same. That's why we are going to prove the first statement, and later on we will say that similarly we can prove the second and third statement. So if you observe the left hand side of this statement is a square is equal to what? We have to prove that its value is equal to b square plus c square minus 2bc cos a. Since the cosine angle of a appears in this expression, that's why we can say that it is cosine rule. So now to prove the first statement, so try to understand it, the method which you are applying to prove the first statement. For that purpose, observe the left hand side very carefully. What is left hand side? A square. If a square is the left hand side, at that time take the vertex A of this triangle ABC at the origin. Okay, whenever we are going to prove the second statement, at that time take the vertex B at origin, and to prove this third statement take the vertex C at origin. So we have considered one vertex, which vertex? A, which is at origin. Now which are the remaining two vertices? B and C. So either we are able to take B on the positive direction of x-axis or C on the positive direction of x-axis, that is our choice. So as it stand here, I am taking, let the vertex B is along the positive direction of x-axis. Now which is the remaining vertex? Vertex C. Now here we know that sum of three angles of a triangle is how much? 180 degree. Its meaning is that angle A, तीनों का sum अगर 180 है, so each angle should be less than 180. So if the measure of this angle is less than 180, means it lies in between 0 to 180. If this angle A is acute, at that time vertex C lies in first quadrant. If the angle A is obtuse angle, at that time vertex C lies in second quadrant. Means definitely vertex C lies above the x-axis. Okay, so here definitely vertex C is above the x-axis, because measure of angle A is in between 0 to 180. So here what is our supposition? Take vertex A of triangle ABC at origin. So we have taken vertex at origin, and vertex B is along positive direction of x-axis, is along positive direction of x-axis, and that's why we can say that therefore vertex C is above x-axis. So hope the idea about why the vertex is above x-axis is clear to you, because the measure of this angle is in between 0 to 180. So if it is acute, means vertex C lies in first quadrant. If it is obtuse, it will lies in second quadrant. Means definitely it will be above x-axis. Now we are trying to find out coordinate of these three vertices. So this implies that coordinate of vertex A. So vertex A is at origin, means definitely its coordinates are 0, 0. Now let us try to find out coordinate of vertex B. B is a point on x-axis, so that's why we can say that its y coordinate will be equals to how much? Y coordinate is 0. Now we are trying to find out x coordinate of point B. Now in this triangle, we know that side opposite to vertex is denoted by small c, side opposite to vertex A is denoted by small a, and side opposite to vertex B is denoted by small b. So here length of this segment AB is equal to c. And what is the definition of x coordinate? It is distance of this point from y-axis, and this distance is equal to how much? C. That's why we can say that here x coordinate will be equals to C. Now we are trying to find out coordinate of point B. For that purpose, we are revising once again the relation between Cartesian coordinate and polar coordinate, which we have discussed in the last video. What we have seen, if r is the distance of the point from the origin and theta is angle made by this OP with positive direction of x-axis, then this r and theta are called as polar coordinate. And in the last period, we have proved one relation between Cartesian coordinate and polar coordinate, Cartesian coordinate, if we are denoted by xy, then what we have proved here, x is equal to r cos theta and y is equals to what, r sin theta. So this result we have proved in the last video. So now let us use this result to find out coordinate of this point C. So here first we are finding x coordinate. What is here x coordinate? R cos theta. R means distance of this point from the origin. Instead of r, here distance is what? B. So here instead of B we will get r. R cos theta. Theta is angle made by this segment with positive direction of x-axis. Here angle made by AC with positive direction of x-axis is how much? It is angle A of this triangle. So means here angle, instead of angle A, here angle we have denoted by theta. In the same way, y coordinate is b sin theta, but theta is what here? A. Instead of r we have taken b because b is the distance of this point from the origin. So using relation between Cartesian and polar coordinate, we will get the coordinate of point C, and C has coordinate. What are the coordinate? B cos A and B sin A. Once the coordinate of all the three vertices are known to us, now we will focus on our required result. So now let us try to find out value of A square, and we will try to show that value of A square is equal to B square plus C square minus 2BC cos A. So here we can observe that A means what? BC. So A square means, can I say that BC square? So which is equals to, now to find out distance between these 2 points BC, we are applying distance formula. So check that coordinate of B is also known, C is also known. If coordinate of 2 points is known to us, we are able to apply distance formula to find out distance between them. What is that distance formula? Under root x2 minus x1 whole bracket square plus y2 minus y1 whole bracket square. But here not necessary to take root because already square is there. Because of this square, root will get eliminated. Now here x2 minus x1 means what we will get here? B cos A minus C whole bracket square plus y2 minus y1 means B sin A minus 0 whole bracket square. Okay, so remaining part is just to simplify it. So first we are finding expansion of first bracket. What will be its expansion? B square cos square A minus 2BC cos A plus what? C square. And here difference of these two terms is B sin A, and square of B sin A can be written as B square sin square A. Okay, so now we are collecting the terms of B square. If we are taking B square common from these two terms, so what is our left hand side? A square. So if we are taking B square common, what we will get here? Cos square A plus sin square A. Just simply we have taken B square common from these two terms. Keep these remaining two terms as it is. What are the remaining two terms? Plus C square minus 2BC cos A, keep it as it is. Now according to trigonometric identity, cos square A plus sin square is 1. 1 into B square is how much? B square plus C square minus 2BC cos A. This is the value of what? A square here. So in this way we have got the value of what? A square. Now same method we are applying to prove these two results. So since we are applying same method, that's why we can say that similarly. So similarly we can prove that. Similarly we can prove that. We can prove that. What we can prove? That B square is equal to C square plus A square minus 2CA cos B, and C square will be equals to A square plus B square minus 2AB cos C. And this completes the proof of what? Cosine rule. Now this cosine rule can also be stated as, so write down it as a note. Cosine rule can also be stated as. So first result. Now we are simplifying this expression. Try to understand its simplification. So this minus term on this side will become what? Plus. Means what we will get? 2bc cos a. Okay, just try to understand. This minus term on this side will become plus, and plus a square on this side will become minus a square. Means b square plus c square minus a square. This 2bc is multiplied on this side. On this side it will get divided 2bc. Means what result we have got here? Cos a is equal to b square plus c square minus a square upon 2bc. Means simplifying this expression we will get this result. What result we have got here? Cos a is equal to b square plus c square minus a square upon 2bc. So using this method we are simplifying, or we are able to state cosine rule. Means cosine rule can be stated in this form also, or it can be stated in this form also. Now from the second result we are able to find out value of cos b. लेकिन अभी आपको ये लर्न ही होना चाहिए. अगर यहाँ पे एंगल a है तो न्यूमरेटर में तीनों भी टर्म है. विच थ्री टर्म? a स्क्वायर also, b स्क्वायर also, c स्क्वायर also. तीनों भी टर्म है, लेकिन यहाँ पे एंगल a अगर होगा तो a स्क्वायर माइनस में होगा. Getting it? और डिनोमिनेटर में a एब्सेंट होगा. ओके, सो इन दिस वे वी आर एबल टू फाइंड आउट वैल्यू ऑफ cos b. अगर b है तो यहाँ पे क्या आएगा? c स्क्वायर प्लस a स्क्वायर, और b स्क्वायर क्या होगा? माइनस, और डिनोमिनेटर में b की टर्म नहीं होंगी. मीन्स व्हाट वी आर गेटिंग? 2ca. ओके, lastly let us try to find out value of cos c. cos c, तो c माइनस होगा c स्क्वायर. सो व्हाट आर द रिमेनिंग टर्म? a स्क्वायर प्लस b स्क्वायर माइनस c स्क्वायर, एंड इन द डिनोमिनेटर 2ab. in the denominator c will be 2ab. c absent रहेगा denominator में. In this way cosine rule can also be stated in this form. While solving the example, means 99% we are using these results, or we are substituting these values. Cos a can be replaced by this value, cos b can be replaced by this value, and cos c can be replaced by this value. Means in 99% example we are using cosine rule, which is stated in this form. So in this way we have completed what? Cosine rule. Now let us try to prove one of the very important theorem, which is called as what? Projection rule. So now let us try to prove the projection rule. In projection rule we have to prove that a is equal to b cos c plus c cos b. Similar type of results are there for b and what? C. The method to prove the first result and second two results are same. That's why we are going to prove one result, and in remaining cases we can say that similarly we can prove the remaining two results. Okay, so here two methods are there to prove the projection rule. So first we will discuss easy method, and later on we will discuss the method which is given in what? Textbook. But while solving the while giving the proof in examination, so definitely preference should be given to a textbook method. Okay, so now here if I am considering here left hand side, right hand side, what is the right hand side? B cos c plus c cos b. Now we can observe that in this expression two terms of cos are there, so we are able to use cosine rule. Now considering this right hand side, we have to show that its value is equal to left hand side, means will be equals to a. So let us check whether we will get a or not. According to cosine rule, value of cos c will be equals to what? A square plus b square minus c square upon 2ab. Here plus c, keep it as it is. And what is the value of cos b? Cos b is equal to c square plus a square minus b square upon 2ca. Here we can observe that this b and b will get cancelled. Here c and c will get cancelled. Now we can observe that denominator of both the terms are same. Since the denominators are same, so take the addition of numerator. What is the numerator? Here a square plus b square minus c square, and here numerator is plus c square plus a square minus b square. Let us check which terms will get cancelled. Plus b square minus b square will get cancelled. Minus c square plus c square will get cancelled. And here a square plus a square will be equals to 2a square. In the denominator 2a, keep it as it is. A will get cancelled, and one a from a square will get cancelled. So what will get here? A. Means in this way, considering right hand side, we have got the value of what? Left hand side. But don't apply this method if the question is asked in examination as an what? Theorem. So So now let us discuss the different cases in the textbook. They have proved projection rule in different 3 cases. So let us discuss about these different 3 cases and use this method while solving it in examination. Okay. Now here we are considering this triangle ABC. Since ABC is a triangle, means there are 3 possibilities. May be possible that this triangle is acute angle triangle, or obtuse angle triangle, or right angle triangle. For all these 3 cases, we are going to prove the first statement, and later on we can say that similar method can be used to prove the second and third statement. So in this triangle ABC, so let AD be the perpendicular to base BC, and we know that side opposite to vertex A is denoted by small a, side opposite to vertex B is denoted by small c, and length of side opposite to vertex C is denoted by small c. Now we are supposing that in case first, let B and C are acute angles. If in this triangle, if B and C are the acute angles, then already these things we have shown in the figure, that B and C are acute angles. Now we are finding projection. What is the name of this theorem? Projection rule. So that's why we are trying to find out projection here. Okay, so now A is nothing but here projection. That's why here A is also projection, B is also projection. See, first try to understand what is the meaning of projection. Let us suppose that one side is there, say side AB, and another segment is there, say AC. Now we are discussing how to find out projection of this AC on AB. For that purpose, from this point C, draw one perpendicular on this side AB, and let us denote the foot of perpendicular by M. Then this AM, this length of segment AM, it's called as projection of AC on AB. So here in this case we can observe that from this vertex a perpendicular is drawn on BC, and foot of perpendicular we are denoting by D here. So that's why this BD is nothing but projection of this AB on BC. So here we can say that, so therefore BD is projection of which segment? AB. On which segment? BC. In the same way, we can observe that this CD is nothing but projection of AC on which segment? On segment this BC. Here CD is projection of AC on BC. So, and CD is projection of AC on which segment? BC. Projection of AC on BC. Now we are trying to find out value of BD and value of CD here. To find out value of BD, so we are considering this triangle ADB. Is it a right angle triangle? So since this is right angle triangle, so that's why we can say that cos B is equals to, what is the definition of cosine function? Cos B is adjacent upon hypotenuse. Means what we will get here? BD upon AB, but AB can be replaced by AB, what is the value of AB? Length of AB we have denoted by C. So which implies that, here BD is there. So BD will be equals to C cos B. BD is equal to C cos B. In this way we have got the value of BD. Now we are trying to find out value of CD. To find out value of CD, we are considering this triangle, this CD. चलो अब ये result compare करेंगे. So that's why we are not using this method. Directly we are writing here similarly CD will be equals to, now here what is the value of BD? BD is equal to C cos B. तो CD की value क्या होंगी? B cos C. So using same method, so B cos C. Now we are focusing on our required result. We have to find out value of A. So now we can say that here. So now A will be equals to, observe the figure very carefully. Can I say that A means equal to BC? So length of BC we have denoted by A. But BC, can I write this BC as BD plus CD? So it can be written as BC BD plus CD, BD plus CD, so which is equal to, keep this left hand side A as it is. Now we are substituting the value of BD, which is already known to us. What is the value of BD? C cos B plus, now we are substituting the value of CD. Just now we have got the value of CD is equal to B cos C. In this way we have got the value of A. A is equal to what? C cos B plus B cos C. So in this way we have got our first result. A is equal to B cos C plus C cos B, which can also be written as C cos B plus B cos C. So we have proved this first statement if the angles of this triangle are what? Acute angle. Now we are considering second case. So case second. In this case we are considering that let B is obtuse angle. Let B is obtuse angle. Okay. Now if B is obtuse angle, then from this vertex A draw a perpendicular. Already here we have written that AD is perpendicular to what? BC, and all these things we have shown in the figure. Now we are finding what? Projection. So here can I say that this BD is nothing but projection of what? AB on which segment? BC. So here BD is projection of AB on BC. And here even we can observe that this CD length CD is nothing but projection of what? AC on which segment? BC. And CD is projection of AC on BC. Now we are trying to find out value of what? BD and CD. So therefore cos, now to find out BD is nothing but side of this triangle. So we can observe that BD is the side of which triangle? ADB. So we are considering this triangle. In this triangle, so if what is the measure of this angle? If this angle is B and these two angles are linear pair angle. Linear pair angle means their sum is 180. 180 can also be denoted by what? Pi. Means if this angle is B, means definitely this angle is how much? 180 minus B means pi minus B. So here we can say that cos pi minus B. And what is the definition of cosine? Adjacent upon hypotenuse. Means here BD upon AB. So which is equal to, keep this BD as it is, hypotenuse AB. AB is nothing but side of this triangle and AB is the side opposite to vertex C. So that's why its length is denoted by small c. And AC is the side opposite to vertex B. So its length is denoted by small b. And BC is the side opposite to vertex A. So its length is denoted by what? Small a. So now AB can be replaced by C. So this implies that BD is equals to, what is the value of BD? C will get multiplied on this side. So C into cos pi minus B. So implies that BD is equals to, but we know that cos pi minus theta is minus cos theta. Means here we will get minus cos B. Minus cos B into C will be minus C cos B. Okay, in this way we have got the value of BD. Now we are trying to find out value of CD here. CD is the side of which triangle? Triangle ADC. So that's why we are considering this triangle. In this triangle, we can say that cos C is equals to, for this angle C, this CD is the adjacent side and AC is what? Hypotenuse. Means what we will get? CD means adjacent upon hypotenuse. Hypotenuse is AC. So CD upon, but length of AC can be denoted by B. So which implies that CD is equal to, take B on this side. So what we'll get here? B cos C. Once these two values are known to us, which two value? BD and CD, then focus on our required result. So our, what is left hand side? A. So therefore A is equals to, we can observe that A is nothing but length of which side? BC. Length of side BC. Now this BC, can I write this BC as CD? अगर CD में से BD अगर subtract कर दिया, so what we will get? BC. Means BC can be written as CD minus BD. So it can be written as CD minus BD. So which is equal to, now we are substituting the value of CD. What is the value of CD? B cos C minus, keep it as it is. Now we are substituting the value of BD. What is the value of BD here? Minus C cos B. So which is equal to B cos C, keep it as it is, minus into minus will become plus, and here we will get C cos B. In this way we have got the value of A. In second case also, what we have proved here, A is equal to B cos C plus C cos B. So in the second case, if the triangle is obtuse angle triangle, at that time also we are getting this result. Now in the last case, let us suppose that this triangle is what? Right angle triangle. So now here case third. Case third. In this case third, we are supposing that B is right angle. So let us see what we will get if B is what? Right angle. So well, B is what? Right angle. So let us suppose that in this triangle B is what? Right angle. Right angle means its measure is equals to 90 degrees. So ABC is right angle triangle. If this triangle is right angle triangle, then according to our supposition, AD is what? Perpendicular to BC, means from this vertex A, draw a perpendicular on BC, and that foot of perpendicular we have denoted by what? D, means B and D coincides each other in case of what? Right angle triangle. We know that side opposite to angle A we are denoting by A, side opposite to angle B by B, side opposite to angle C by small c. Now here we can observe that this BC is what? Projection of this AC on BC. So here we can say that BC is projection of AC on which segment? BC. So therefore cos C is equal to, let us try to find out value of cos C here. Cos is adjacent upon what? Hypotenuse, means what we will get here? Adjacent means BC upon hypotenuse means AC. So BC, keep it as it is, AC can be replaced by, what is the value of AC? B. So which implies that BC is equal to B into cos C. So means B cos C. Okay, now we are considering here right hand side, and considering right hand side we will try to show that its value is equal to left hand side, means small a. So use this method only in last case. So now we are considering right hand side. What is the right hand side here? B cos C plus C cos B. So which is equal to, already the value of B cos C is known to us. What is the value of B cos C? BC plus C into cos B, but B is how much? 90 degree. B is equal to 90 degree because this triangle is what? Right angle triangle. So BC means, can I say that small a? So its value is equal to small a, and we know that cos 90 is equal to 0, and 0 into small c will be equals to 0, which is equal to a. Means that is what result we have got here? A is equal to what? B cos C plus C cos B. So in this way, in the third case also we have shown that A is equal to B cos C plus C cos B. Now try to understand here. So in the first case, angle B is what? Acute angle. In the second case, B is what? Obtuse angle. And in the third case, B is what? Right angle. Now again, if you'll observe case first very carefully, C is what? Acute angle. So we have not proved the result for C as obtuse and C as what? Right angle. Only we have proved this result if C is what? B के लिए सब result हो गए. B यहाँ पे acute था, यहाँ पे obtuse था, वहाँ पे right था, right angle था. अभी C में यहाँ पे acute था, लेकिन हमने क्या नहीं किया है? We have not proved this result by considering C as what? Obtuse and C as what? Right angle. But same method we are applying in these two cases also. So not necessary to write again to prove again two cases, one for C is obtuse and one is C is for right angle. So here directly we are writing, we can using same method, we are able to prove this result for C to be what? Acute, and C to be obtuse and C to be what? Right angle. So here we can say that same cases we can prove for C to be acute, C to be obtuse and right angle. Okay, so hence we can say that in all cases value of A is equal to B cos C plus C cos B. In this way we have proved first statement. Now to prove the second and third statement, same method is used. So similarly we can say that we can prove that what we can prove that B is equal to C cos A plus A cos C, and C is equal to A cos B plus B cos A. In this way we have proved projection rule. So cosine rule or sine rule or projection rule are one of the very important formulas which can be used while solving example. In the next video we will prove applications of sine rule, cosine rule and projection rule.